So in this video, we're going to look at maximizing profit, and we'll look at a few examples. This first one, we're going to find the maximum profit, find where the maximum profit happens, find the maximum profit, and then verify that it is a max. So it says, suppose a company has developed this yearly profit function, P of XY. X is the number in thousands of standard products. Y is the number in thousands of the luxury products produced per year. P is the yearly profit in thousands of dollars. A says how many of each type of product should be produced to realize a maximum profit. Okay, so whenever I want max, I need the partial with respect to X, and I need the partial with respect to Y. I'll put that down here. Okay, so with respect to X, I treat anything with a Y as a constant. So negative 66 X squared, I multiply negative 66 by 2, and I get negative 132. X, 2 minus 1 is 1, so it's just X to the first or X. Okay, so for 132XY, what I'm doing is I take 132Y, I put the Y with the number in front, and that just is considered like the number in front, and then I take the derivative of X, which is just 1. Okay, and so when I do 132Y times 1, I really just get 132Y. Okay, negative 99Y squared, that's all Y's, so the derivative of that is 0, so I don't need to write it. 132X is 132, 66Y, 0, 19, 0. So this is my first derivative with respect to X. I'm going to do Y. So 66, negative 66X squared, there's no Y term, so the derivative is just 0, so we don't need to write it. 132X, it's the same thing. 132X, we put that in front. That's the constant in front. The derivative of Y is just 1. So 132X times 1 is just 132X. Negative 99Y squared, I'm going to do negative 99 times 2, which is negative 198, and then Y to the first. 132X is a constant, so it's 0. Negative 66Y is negative 66, and 19 is a constant. So I need to find the critical points. To do that, I set both of these equal to 0. And the problem is I can't just find X or Y easily in this problem. I have an X or Y in both partial derivatives. And so what I have here is a system of equations that we're going to have to solve. And generally for these, the easiest way is to solve by elimination, which hopefully you've learned before in another class. So what I'm going to do is I'm going to move the constant at the end to the other side by either adding or subtracting it. So here I would subtract 132, and I'd subtract 132, and 0 minus 132 is negative 132. And here I would add 66. And 0 plus 66 is 66. Okay, so the goal here is to get the X's or the Y's to add to 0, which means they cancel out, and then we can solve for the other variable. To do that, we need the numbers to the coefficient of either the X or the Y to be the same number and opposite signs, which does happen with my X's, so I don't have to do any work to make that happen, and I can just add the two equations. These add to 0, so we cross it out. 132Y plus the negative 198Y is negative 66Y. And negative 132 plus 66 is also a negative 66. So now I can solve for Y, and I get Y equals a positive 1. Now that I know Y, I'm going to substitute it in for either equation. It doesn't matter. I'm just going to do the first one. So from here, I'm going over here. And I'm going to solve for X. Okay, so I'm going to, in order to solve for this, subtract the 132 from both sides. Okay, so I get negative 132x equals negative 264. And then I'm going to take negative 264 and divide by negative 132, and I get x equals 2. So this is my critical point. It's the solution to this system of equations. So this is my critical point. Okay. So because it's our only critical point, most likely this is a max. In part C, we are going to have to verify it if it's verify that it's a max there. If we didn't have that part in here, I would then verify it in part A, but because they asked it in C, I'm going to wait. So what this means is x is 2. So we should have 2 thousands of standard products. And 1,000 of, I believe it was luxury products. Yeah. So that should be where the max is. Like I said, we're going to verify it's a max in part C. So I'm going to wait to do that part. So then it says, what is the maximum profit? So I'm going to plug in 2 for x, 1 for y into my original function. So I just write my original function down here so we can see it. So it's negative 66x squared plus 132xy minus 99y squared plus 132x minus 66y and then minus 19. Okay, so for 2, 1, I'm going to plug anywhere I see an x, a 2, and anywhere I see a y, a 1. Okay, I'm just going to plug this into my calculator. Okay, and I get 80. So again, they said it's the yearly profit in thousands of dollars. So we're really getting 80,000. Is my profit. Okay. And then C is making sure we actually found a max. So we should always verify this. A lot of these questions will ask you it later on. So it says show using calculus that the critical point in the problem is a max. Okay, so I need to come back because I need my partials and I have to take the partial xx, the partial yy, and the partial xx. So let's write all our first derivatives down here so we don't have to keep scrolling. So these are my 2 partial derivatives. So P of xx is just taking the derivative of this with respect to x. So the derivative of negative 132, x is negative 132. This is a constant, this is a constant. So the derivative of both of them are 0. And I just get negative 132. The partial of y with respect to y, take the derivative of this, 0. The derivative of this, negative 198. The derivative of negative 66, 0. So I just get negative 198. And if you have to write that all out, that's fine. You can write it as 0 plus negative 198 plus 0, and then simplify it to this. And then I need the derivative of p of xy. So I'm going to take the derivative of p of x with respect to y. So now I'm treating x's as constants. So this is 0, this is 132, and this is 0. So I just get 132. And then I use my D equation, which I would just keep writing to help you memorize it. So, I mean, it's f of xx. We're going to do p in this case. So p of xx times p of yy minus p of xy squared. And again, we're doing it at the point 2, 1, but in this case, again, we have all constants, so it's not going to matter. We don't have to plug anything in. So it's just going to be negative 132 times negative 198 minus 132 squared. Which is 8712, which is definitely greater than 0. So again, anytime a D is greater than 0, we have a max or a min. We have to look at the sign of P of XX, which is negative 132, so it's less than 0. So since we're verifying it, you should write this out. Since D is greater than 0 and P of XX is less than 0, 2, 1 is a relative max. Okay, so that's one example of a profit function, and then I'll do another video with another example.